Before you guys watch this video, I want to let you know there's a lot of information in these sessions, and I would recommend watching these sessions 2 to 3 topics at a time and taking a break. It's much easier to take in all the information. This one is going to go over problem solving and data analysis. It's a little bit of a smaller section on the SAT, and it's got a wider range of questions, so it's a little bit tougher to cover. And this is still a really important day, but like it's not going to be as important as like the algebra stuff. But it's something like less people know about, so that's why I'm spending a lot of time going over it. This first slide is going to be a review from our first tutoring session. This is about analyzing one variable data. These questions will talk about the range, mean, or median, mean, standard deviation, and frequency. The range is the maximum value of the data set minus the minimum value of the data set. The median is the middle value of the data set. So let's say we had like 2, 2, 4, 6, 7, 10, 11. Then the middle value would be 1, 1, 2, 2, 3, 3. The middle value would be 6. That's how you would find the median. Or you could just type it into Desmos. Desmos would give you the median the same way. The mean is the average of all the values. You can also type that into Desmos. If you have a data set, you could do mean of, say, let's say our data set is 2, 2, 4, 6, 7, 10, 11. I believe this is the same one. The mean of this data set would be 6. You can just type it into Desmos and it works perfectly. So, standard deviation as it is used on the SAT. In stats or something, you would usually have to calculate the standard deviation. Standard deviation is never calculated on the SAT, or at least not with any of the problems I've ever seen. They could add new problems in that you have to, but I don't think they ever will. But the way they use standard deviation is they're always talking about spread. So they might give you like 2 graphs and ask you which one has the higher standard deviation. And your second graph is spread out more from its mean, so it's going to have the higher standard deviation. Or they might give you a dot plot, something like that. You'll see it in some of the practice questions I have. And then frequency. A lot of tables the SAT puts in their questions, they talk about frequency. Frequency is basically the amount of times a number pops up in a data set. If I had a data set that was like 2, 2, 2, 2, 4, 7, 7, my chart could look like this. This would be number, and I'm just going to do FREQ for frequency. Let's say the number is 2. 2 appears 4 times in this data set, so the frequency would be 4. Let's say the number is 4. 4 appears 1 time in this data set, so it would be 1. Let's say the number is 7. 7 appears 2 times in this data set, so the frequency would be 2. That is how they use frequency on the SAT. I've honestly never seen it in any other type of charts be used like that, but yeah. So let's go through a few practice problems. The dot plot represents the distributions of values in datasets A and B. Which of the following statements is true? The median of dataset A is equal to the median of dataset B, and the standard deviation of the dataset A is equal to the standard deviation of dataset B. So if we look at these dot plots, let's look at the median first. One thing you can know to get this answer is that if a dot plot is symmetrical, the median is always going to be where the axis of symmetry is. Both of these dots are symmetrical down 13. So it would be symmetrical along this axis. So the median would be 13. And same for this one. It's mirrored on both sides at 13. So the median would be 13. But if you want to, you can count and cross out bars. These two cancel out these two. These four cancel out these four. These two cancel out these two, and you're left with a median of 13. This cancels out this. These four cancel out these four. These two cancel out these two. And then you're still left with your median of 13. So the median of dataset A is equal to the median of dataset B. So 1 is true, so we know it's not B. And we know it's not D, because 1 has to be true. The standard deviation of dataset A is equal to the standard deviation of dataset B. Well, if we look at this, dataset B takes 2 dots from the value 13 and puts them at 10 and 16 respectively. So it throws 1 dot over to 10 and 1 dot over to 16. If you're pulling dots away from the mean, that means your spread is going to be higher, and therefore your standard deviation is higher. So 2 is also true. The standard deviation is... Oh no, 2 is false because it says the standard deviations are equal. The standard deviations are not equal because dataset B has a greater spread than dataset A. Dataset A and B each consist of 27 values. The table shows the frequencies of the values for each dataset. Which of the following statements best compares the means of the two datasets? The mean of dataset A is greater than the mean of dataset B. The mean of dataset A is less than the mean of dataset B. The mean of dataset A is equal to the mean, or there's not enough information. Well, if you look at this chart, dataset A gets a higher frequency towards the higher numbers, and dataset B gets a lower frequency towards the higher numbers. So dataset B has a higher amount of lower numbers, and dataset A has a higher amount of higher numbers. Like, let's say we did this on a graph, and this was dataset A. Then dataset A is going to get bigger as it goes along. If we drew out dataset B, dataset B is going to get smaller as it goes along. Those bigger numbers increase your mean. So the mean of dataset A is going to be greater than the mean of dataset B. Dataset F consists of 55 integers between 170 and 290. Dataset G consists of all the integers in dataset F as well as the integer 10. Which of the following must be left for dataset F then for dataset G? The mean and the median. So, if you plug in 55 integers between 170 and 290, the mean of those integers, because there's no values that are going to be less than or equal to 10, is always going to be greater than 10. And every single number affects the mean. So if you plug in 10, the mean for dataset F will be less than the mean for dataset G. So 1 is correct. Now, for median, that's not necessarily true. Because let's say you have a data set of integers between 2 and 10, but all of the integers are 4s. Let's say you have 5 4s. and then you add a number 1 to this. This doesn't change the median. The median of the original problem is going to be 1, cancel these out. The mean of the original problem is going to be 4, and then the mean of the new problem is going to be, cancel these out, 4 still. So the median does not necessarily have to be less for dataset F than dataset G. So the answer is A, 1 only, because the mean does have to be less. Alright, 2 variable data dash describing lines. So it's going to ask you to describe lines or evaluate slopes quite a lot with these types of questions. It wants you to analyze the slope. It wants you to see if it's positive or negative, if it's a steep slope or not a steep slope, and that changes the slope value. We're also going to be talking about exponential equations here. And to give you a visual, let's say we have f of x, which this is the exponential equation, equals a times b to the x. Let's just set a equal to 1 for now. And then we'll set b equal to 2. When b is greater than 1, as we can see here, it is an exponential growth. So it is an increasing. Uh-oh. 1 second, let me get back here. It is an increasing exponential growth here. When b is less than 1, say b is 1/2, you can see that this function decays. This function's getting smaller. So it's increasing when it's greater than 1, and it is decreasing when it is less than 1. And then a is going to be your y-intercept for your slope, or for your equation. If a equals 1, your y-intercept is going to be 1. If a equals 2, your y-intercept is going to be 2. And so on. If a equals 10, your y-intercept will be 10. What happens if I set a to be negative? If a is negative, the graph is just mirrored. So it's going to look like exponential growth the other way. But this is it's an increasing exponential because it's increasing the whole time. It's just mirrored, as it's a decreasing exponential mirrored along the x-axis. That's what happens when you set a as negative. It's going to just be a mirrored version of what you have when a is positive. So AROC is the average rate of change. And the average rate of change over an interval is used by the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'll show you guys how to use that equation soon. Whoops. Okay. In the given scatter plot, a line of best fit for the data is shown. Which of the following is the closest to the slope of this line of best fit? Well, we can automatically see that the line is decreasing. So it's not going to be A or B, because A or B are both positive. And if a line had a slope that was positive, it would be increasing. Y equals mx plus b is our slope equation. Let's just say our y-intercept is 0, so we just have mx. If our slope is equal to 0.7, it's going to be increasing. If our slope is equal to 7, it's also going to be increasing. So it can't be A or B. So now we have to pick between C or D. Is it decreasing by 0.7 for every x, or is it decreasing by 7? And the window could throw you off sometimes, but it looks to me like it's decreasing by 0.7, or so negative 0.7 for every x. Negative 7 would be a lot steeper unless the window was altered just to make you think that. So the answer to this one is going to be C, negative 0.7. The scatter plot shows the relationship between two variables, x and y. An equation for the exponential model shown can be written as y equals a times b to the x, where a and b are positive constants. Which of the following is the closest value of b? So, we can just set a as an estimate just to make our graph look kind of close to this graph. Let's say our a is 128. Let's get back that equation. F of x equals a times b to the x. And then let's just say a equals 128, just like shown in the equation. It's not going to show the graph yet because we haven't plugged in b. Which of the following is the closest value of b? Well, before I plug anything in, I'm automatically going to know it's a, because if it's anything greater than 1, then it's going to be exponential growth, and we can see that this equation is decreasing. So I automatically know that it's a based off of that. But if we plug in each answer to look at it just in case, this one's decaying. The reason it doesn't look like this graph, as you can see, the x-axis only goes up to 14, while the y-axis goes up to 140. So they look a lot different because of how they have this. And then b, if it was 1.83, it would look like this. That's increasing. C, 18.36. Definitely increasing. That is a super sharp increase. And then 126.35. We automatically know it is A because if it is anything above 1, it's going to exponentially grow, and we can see the graph exponentially or declines. So that's how you know it's A. But you can always plug into Desmos if you need any confirmation. The scatter plot shows the relationship between two variables x and y. A line of best fit is shown. For how many of the 11 data points does the line of best fit predict a greater y value than the actual y value? So I'm going to draw out a kind of sketch of this graph. Not really well, but enough to see. And then here's our line. Boop, boop. Okay, here we go. So this is kind of how our line looks. So it's asking for how many of the 11 data points does the line of best fit predict a greater y value than the actual y value. So you might get tripped up when you see greater and be like, oh, okay, I want to be looking at the points that are above the y-axis. But if the line of best fit is creating a greater y value than the actual y value, it's going to be on the point, and the actual y value would be lower. So we're actually looking at the points below. because at the points below, the predicted line is going to be greater than the actual y value. So we would count the points below: 1, 2, 3, 4, 5, 6, and then we would our answer would be 6. Each year, the value of an investment increases by 0.49% of its value the previous year. Which of the following functions best models how the value of the investment changes over time? So, if it is increasing by 0.49% of the value its previous year, you could write it as increasing by a percent is 1 plus whatever that percent is. So it'd be 1 plus, and you have to convert this outside of percentage, so 0.0049. We don't really need to know what A is here. And then if it's of the previous year, the way you would get that is you would put it to the x. So every year it would grow by 4.49% of whatever the number here is. So it's 1.0049 to the x. We don't need to know what a is for this question. So what function best shows this? A decreasing exponential? Well, we know it's not a decreasing exponential because although this is an exponential equation, the b value is greater than 1, so it would be an increasing exponential. And then b and d are wrong because we know it's not a decreasing linear or an increasing linear. Usually when you're dealing with percents in these type of questions, it's going to be pretty straightforward and tell you that it is an exponential equation, although there are some that try to trip you up when it really is a linear equation. During a study, the temperature in degrees Celsius of the air in an air chamber was recorded to the nearest integer at certain times. The scatter plot shows the recorded temperature Y in Celsius of the air in the chamber X minutes after the start of the study. What was the average rate of change in Celsius per minute of the recorded temperature of the air in the chamber from X equals 5 to X equals 7? So this is where you are going to use that average rate of change, y2 minus y1 over x2 minus x1. So let's get that written out immediately. Okay. So it's this one. You want to go from 5 to 7. So I'm looking at what 0.5 is. The 0.5, and you write it as like xy. When x equals 5, y equals 14. Again, I'm just looking at where it equals 5, and then I'm dragging across on that line to get to 14. When x equals 7, y equals 24. So we have our 2 points. Now you can use either as y2 or y1, or like the second point or the first point. I always like to go with the bigger point. So these are your x's and these are your y's. I'm going to use 7/24 as my y2 and my x2. So y2 would be 24 minus y1 would be 14 over 7 minus 5. This equals 10 over 2, which equals 5. So the average rate of change of the recorded temperature in the air in the chamber from x equals 5 to x equals 7 is 5, and then it would be Celsius per minute. So that's how you use that average rate of change formula. The scatter plot shows the temperature in degrees Fahrenheit and the distance above sea level in feet measured at 6 locations on Mount Jefferson. A line of best fit is also shown. At a distance of 4,000 feet above sea level, what is the temperature predicted by the line of best fit? So we're not looking at any of the points here, we're looking at that line. So we're going to go 4,000 feet above sea level, that would be right here, and then drag across this line, and it's going to look like 35. So your answer is going to be B. They will never give you another number that is super close to B. Like, they'll never put 36 because it's really tough to tell, and like sometimes it looks weird like that. Anyways, on to box plots. If any of you guys want to copy this down, I'll give you a second here to copy this down. Box plots are decently important to remember. I would say out of all the SATs I've taken, I've seen probably 4 questions, so around 1 per SAT. And if you don't know box plots, that's kind of like a loss of 10, 20 points, which they are kind of annoying to remember. I always get the middle part confused, thinking about whether it's the mean or the median. But yeah, they're decently important to remember. I'll have that up there. Handwriting's not the best, but here we go. The box plot summarizes 15 data values. What is the median of this data set? We know this median is going to be that little line in the middle, so the median will be 5, because if you trace it down on this number line, it's right above that 5, so the median is going to be 5. The box plot summarizes the masses in kilograms of the 2 groups of gazelles. Based on the box plots, which of the following statements must be true? The mean mass of group 1 is greater than the mean mass of group 2. The mean mass of group 1 is less than the mean mass of group 2. The median mass of group 1 is greater than the median mass of group 2, or the median mass of group 1 is less than the median mass of group 2. This is where you need to know where that middle is the median and not the mean, because once you see mean with a box plot question, you can automatically cross answers A and B out. Then I go on to the median questions, and looks like group 1's is greater, which C says the median mass of group 1 is greater than the median mass of group 2. So your answer is going to be C, because the median here is greater than the median here. The 2 box plots show the distribution of number of books read over the summer by the students in 2 different English classes. What is the positive difference between the ranges of number of books read over the summer for the 2 classes? So, as we know, the range is the highest value minus the lowest value. So if it wants the positive difference between the ranges, then just take the bigger range minus the smaller range. You can see that class B has a bigger range, so I'm going to do that first. Its maximum is 10, its minimum is 1. 10 minus 1 is 9, so the range of class B is going to be 9. The range of class A is going to be the maximum is 5, and the minimum is 0. 5 minus 0 equals 5. So these are the ranges of each. If it wants the positive difference between the ranges, it wants the first range minus the second range. 9 minus 5 equals 4. So the positive difference between the ranges of the number of books would be 4. Density questions. These ones get a bit hard. I'm not gonna lie, density questions are quite annoying sometimes. So, the best way to tackle these is knowing what they're going to ask you quite a lot. So, the density equation is density equals mass over volume. D equals m divided by v. Density, mass, and then the v is volume. And the questions often ask for more than looking for one value. Some questions will give you the density and the volume, ask you to find the mass, or the density and the mass, ask you to find the volume. But most questions will not. Most questions will have you find the volume first, or find the density first, and give you a different density equation. You want to look for something that helps you find one of the variables in density equals mass over volume, because it's usually going to give you one and then make you find the other. These often appear as harder questions in Module 2, so if you know how to do these, this is a good way to get some of those harder Module 2 questions and a nice way to get some good points. An object has a mass of 168 grams and a volume of 24 cubic centimeters. What is the density of the object? So if density equals mass over volume, we're looking for density. It gives us mass of 168 and then volume of 24. So we just go to Desmos and do 168 divided by 24. That would give us 7, so the answer to this question is 7. Again, this is going to be one of your easier questions. Okay, so the density of a certain type of wood is 353 kilograms per cubic meter. A sample of this type of wood is in the shape of a cube and has a mass of 345 kilograms. To the nearest hundred of a meter, what is the length of one edge of this sample? So it gives you density and mass. And it's asking what one edge length of this sample is. So it wants you to find volume, because if you're going to find volume, a cube volume equals your side lengths cubed, and the edge length is the same thing as the side length. So it wants you to find volume. So it gives you the density 353, and then it gives you the mass as well, 345. And then you're looking for the volume. So you would multiply the volume over 353V equals 345, and then you would divide this 353 over. So volume equals whatever this is, 345 over 353. So this gives you 0.977. Keep that in Desmos, because if your volume equals 0.977, you're looking for side lengths cubed, because you want what one edge length of the sample is. So plug in s cubed for v. So your s cubed is equal to 0.977. And if you want one of those, then you would have to take the cubed root of the whole thing. So to find a side length, you would take the cubed root of this. I'm going to copy this down right here, 0.97733, just to like 5 decimal places should be fine. And then to take the cubed root, I always go to the fraction way of doing it, and then I do 1/3, and it gives me 0.99238. So if I go and look at this, 0.99 is my closest answer, and that is going to be your answer. Is there any confusion on that, how that problem is done? Okay, perfect. There's a lot more density problems. They like to put it in a bunch of different context ones, but it's usually all using edge lengths. They like to use edge lengths a lot for volume. Okay, conversions and converting units. So, these questions are heavily based off the units. They're actually circled around the units. The whole point of this is that you're converting whatever units the problem you have. And there's a very specific way to set up multi-step equations. I'll go over that way in a second. Units being squared or cubed changes the problem quite a lot. So, my specific way to set up a multi-step equation is I like to use a fractional bar. Maybe not that big. Fraction multiplied by fraction multiplied by fraction. And then you write the units you want at the top and the units you write the units you have at the top and the units it's per at the bottom. So let's say you're going to meters per second and you wanted to get rid of, or you wanted to go to something per minute. You wanted to go to meters per minute. So you would put seconds and then per minute at the bottom. And you wouldn't need this first one in this case. There's 60 seconds for every minute. So if you multiply whatever you have by 60, you'll get how much it is per minute. I'll show you that once we get into some of the equations. In units being squared or cubed changes the problem dramatically. Yeah, kind of. So basically, if you have 12 inches in a foot, 1 foot equals 12 inches. 1 square foot does not equal 12 inches. What you want to do to find how many inches a square foot is square both sides of the equation. It's very like weird. It's kind of like I don't know. It makes sense, but I don't like it. So when you square this, 1 square foot, this becomes 1 square foot because 1 squared is 1. And then 12 inches is 144 square inches. So if you tried to change from feet to inches when you had square foot, it's not going to work out at all. It's kind of annoying. They like to trick you up quite a lot with those. Okay, so let's start here. A distance of 354 furlongs is equivalent to how many feet? So you start out with furlongs, 354 furlongs. I'm just going to put FUR. And then I want to get it to feet. So I want to get rid of furlongs. So I'm putting furlong on the bottom here. And then yards on the top. I'll just do Y for that. So there's 220 yards in 1 furlong. And then you want to get it to feet. And you're getting rid of yards here. So put yards on the bottom. And 1 yard equals 3 feet. So basically, I'm going to show you guys how this, the way you do this actually works. The furlongs would cancel out here, and the yards would cancel out. So whatever your final number is, it leaves you with feet. So like once you cancel everything out, it intuitively makes sense. So now we just do the multiplying across. 354 times 220 times 3 is 233,640. And that's going to give you answer choice D. A certain town has an area of 4.36 square miles. What is the area in square yards of this town? So this is where it gets kind of confusing. I'm just going to put m squared. I think that is how you do it. Miles squared. What is the area in square yards? So we want to look for the area in square yards. It gives us that 1 mile equals 1760 yards. So if you square both sides of the equation, 1 mile squared equals, now we have to do 1760 squared. I mean, I could do this in my head. I mean, maybe. And then we would get 3,097,600 yards squared. So 1 square mile equals 3 million and change square yards. So if you want to get it in square yards, you want to get rid of that miles squared. So 4.36 miles squared, and then multiplied by miles squared would be on the bottom, so you can cancel it out. And then yards squared would be on the top. So you put this number in here for the top. If you guys have trouble reading anything that is quite small, just let me know. And then you would just multiply 4 by that big number. So 4 times 3,097,600. And that would give you 12,390,400. Oh, 4.36, sorry. 13,505. And that is going to give you answer choice D. What I got wrong originally was I only plugged in 4 square miles when it was 4.36. Okay. The area of a rectangular region is increasing at a rate of 250 square feet per hour. So, which of the following is the closest to this rate in square meters per minute? So, we want to change. Let's start out with what we have. We have 250 square feet. So, just do feet squared. And then per 1 hour. Per every hour. So, one thing you want to do is get it in minutes. So let's cancel out that hour and make it minutes. So hours would go on top and minutes would go on the bottom. There's 60 minutes in an hour. So you would put 60 on the bottom. And then these hours would cancel out. Now we have it in feet squared per minute, or square feet per minute. So we want to get it out of square feet per minute and get it into meters or square meters. So feet squared would go on the bottom, and then meters squared would go on the top. So 1 meter equals 3.28 feet. We have to square both of those to get how many square feet are in a square meters. 3.28 squared. That's going to be 10.75. So in 1 square meter, there's 10.75 square feet. So now the feet squared come out, and now we can see we have meters squared per minute. Is that what it wants? Square meters per minute. Okay, so we have the right stuff written down now. So now we do 250 multiplied by 1 over 60 multiplied by 1 over 10.75. And that would give you 0.387. That's really close to 0.39, so you know your answer is going to be A, 0.39. If you guys need, because this is really important, this is another one of those questions where there's likely going to be one hard question, like a question 20 in Math Module 2 on this specific thing. So if you're really going for that high score, I would write down how you do this somewhere, where like the basis is fraction times fraction times fraction. You will usually only need 3. I don't think I've ever seen one where you need 4. Ratios and dilating ratios. This is a little confusing. You guys will get it once we do some problems in context. X per y is equal to x over y. And that might look confusing at first, but how you explain it is like we had meters per second. So if we had 3 meters per second, it would just be 3 over 1. That's your ratio every meter per second. It'd just be 3 over 1. So x per y is literally x over y. We did that a little bit in the last piece. And what does this looks like in context? I already showed the meters per second thing. Let's say a bird flew 10 feet every second. So 10 feet every second. That would be 10 feet over 1 second. And the units in these aren't going to matter as much. Conceptually, it's good to know like what units are there. Sometimes they might try to trick you up with the units, but I don't think I've seen any questions like that before. When dilating ratios, set 2 of these ratios equal to each other. So what I mean is, let's go back to the bird thing. If a bird flies 10 feet for every second, how many seconds, so we're looking for a certain amount of seconds, does it take for it to fly 30 feet? The top is feet, the bottom is second. So you want to find how many seconds it takes it to fly 30 feet. Cross multiply. 10x equals 30, because 30 times 1 is 30. 10 times x is 10. divide over by 10, x equals 3. So you would know it takes 3 seconds to travel 30 feet. That would be like a problem in context. And it always asks about this in context. Like, that's, this looks confusing out of context. That's why once we get into the practice problem, it's going to be much easier to understand. A species of bird can fly at an average speed of 16 meters per second when in continuous flight. At this rate, how many meters would this bird species fly in 4 seconds? So you have 16 meters per 1 second equals, so it wants to know how many meters, so it would be x meters over 4 seconds. You would cross multiply again. 16 times 4 is 64. 1 times x is x, so x equals 64. The bird would fly 64 meters in 4 seconds. A mechanical device in a workshop produces items at a constant rate of 60 items per hour. So 60 I per 1 hour. At this rate, how many items will be, okay, so we're looking for items. So X items will be produced in 3 hours. So over 3 hours, cross multiply, 180 equals X. So 180 items, the mechanical device will produce 180 items in 3 hours. A customer spent $27 to purchase oranges at $3 per round. So, $27 in oranges and $3 per round. Per pound, sorry. Per pound. It doesn't give us $27, so we'll just have the dollar sign up here. It doesn't give us how many pounds it does here, so we're going to set this as X. And it is $3 per 1 pound. So we're looking how many pounds of oranges did the customer purchase. That's how I know how to set X equals here, because it told us the money and it wants us to find how many pounds. So you would cross multiply again. X times 3 is 3x. 27 times 1 is 27. Divide over the 3. X equals 9. And 9 would be your answer. 9 pounds of oranges. At a particular track meet, the ratio of coaches to athlete is 1 to 26. So 1 coach for every 26 athletes. If there are X coaches, so we know there are X coaches, which of the following expressions represents the number of athletes? So we're looking for the number of athletes. Well, we're looking for what this is equal to. So I'd set this as a variable. I'd set this equal to y. So we want kind of y equals, and then we want the rest of the equation. So we're going to get y by itself to find the rest of the equation. So you would cross multiply. Y times 1 is y. X times 26 is 26. So y equals 26x. So your answer would be B, 26x. All these questions are about is knowing what the context is in setting your equation in context. Ratios seem a little bit confusing at first. I was very confused with ratios at first. Why is the camera so blurry? probability and conditional probability. So, with probability and conditional probability, you want to check if there is a condition. And this is usually shown by given or if. We will get into how that works once we get into some practice problems. You want to find what your probability is, and your probability is what you are looking for divided by everything overall. And that is unless there is a given condition. If there is a given condition, then it's what you're looking for divided over given. And I'll show you guys how that works. So a data set of 3 numbers is shown. If a number from this data set is selected at random, what is the probability of selecting a negative number? Well, we know there's 3 numbers in the data set, and there's no given, so our overall would be divided by 3. And what we're looking for is the negative numbers, and there's 1 negative number. So our probability would be 1 over 3 to find that negative number. The table gives the distribution of votes for a new school mascot and grade level for 80 students. Now this is how the SAT will ask this question very, very often. If one of these students is selected at random, what is the probability of selecting a student whose vote for the new mascot was for a lion? So out of the 80 students, there's no given. It says if one of these students is selected at random. That's your important. That tells you that there's no given, because it doesn't say given that blank on the end. So your all is going to be over 80. What is the probability of selecting a student whose vote for a new mascot was for a lion? So we're looking at lion 9 plus 2 plus 9, it gives us 20, so there were 20 total votes for lion. So your ratio would be 20 over 80. Now, you can put 20 over 80 into Desmos, and I believe it gives you a fraction bar right here that simplifies the ratios automatically for you. So 20 over 80 is also equal to 1 over 4, and 1/4 is your answer. The table summarizes the distribution of age and assigned group for 90 participants in a study. One of these participants will be selected at random. What is the probability of selecting a participant from group A given that the participant is at least 10 years of age? So you see that given statement, so you know that this is a given question. So it's not what you're looking for overall, it's what you're looking for over given. So now we want to find what that given is. So it's that if the participant is at least 10 years of age. So that gets rid of 30 people, because the total amount 0 to 9 years is 30. So now we know the rest is equal to 60, because 10 to 19 years is 30, and then 20 plus years is 30. 30 plus 30 equals 60. So our over given is going to be over 60. That is a really ugly 6. 60. So it's asking what is the probability of selecting a participant from group A. Now, it's not going to be 30 over 60, which is the total amount in group A, because 7 of those are 0 to 9 years. You want to subtract that 7 out because it's given that the participant is at least 10 years of age. So 14 plus 9 is all of yours from group A for the problem. This equals 23 over 60. So that's how you would get the answer to that problem, and the final answer was 23 over 60. So, margin of error. The SAT likes to use the word plausible. In most of these, you're just creating an interval with your margin of error. It gives you the margin of error, and you want to create the interval. It's never asked you to solve for a margin of error, and I do not think it ever will. And then kind of a skeleton sentence it uses is, it is plausible to assume that, and then whatever your context is between the margin of error interval. This is a newer SAT question type. I think I've seen one of these on an SAT and that's it. But they just added some new ones to the SAT bank, so these might appear on the March SAT. They always do new questions every March one. They do new questions every time, but March is the first runaround, so they'll do more new March questions. Practice problem. A company that produces socks wants to estimate the percent of the socks that produced in a typical week that are defective. A random sample of 310 socks produced in a week are inspected. Based on this sample, it is estimated that 12% are defective, with an associated margin of error of 3.62%. Based on the estimate and associated margin of error, which of the following is most appropriate conclusion about the socks? 3.62% of the socks are defective. That is not how margin of error works. Margin of error is going to give you an interval that are defective, and it's not going to be based around the margin of error. It's going to be based around the estimate, which is 12% in this problem. It is plausible that between 8.38 and 15.62% of the socks are defective. That already solves our margin of error. Let's look at the other three first, just in case the other two first, just in case we might not have to do any math. But it could be B. 12% of the socks are defective. Well, it says it's estimated that 12% of the socks are defective, but it has that margin of error. The margin of error that is there because the actual number of socks that are defective might not be 12%. And it is plausible that more than 15.62% of the socks are defective. Well, let's go ahead and solve for our margin of error. So our margin of error interval is going to be 12 plus or minus. That is your plus or minus sign. I'll write it out a little bit better. Plus or minus, and then 3.62. So this is going to give you your percentage. Now there's no plus or minus sign in here, so you're going to have to do 12 plus 3.62 and 12 minus 3.62. So your interval is going to be 8.38 to 15.62. That kind of looks like a 3. Okay, so it is plausible that between 8.38 and 15.62 socks are defective. Well, if we go back, that is kind of the skeleton sentence that margin of error uses on the SAT. That the context is between the margin of error. So yes, B would be your correct answer. And the reason it's not D is because your margin of error is supposed to show you where it's probably going to be. So if it's not in the margin of error, it's probably not going to be there. For a population of 50,000 people, 1,000 were chosen at random and surveyed about a proposed piece of legislation. Based on the survey, it is an estimated that 35% of people, so 35 is your estimate, 35%, with an associated margin of error of 3%. Based on the results, which of the following is a plausible value for the total number of people in the population who support the proposed legislation? Well, there's a total population of 50,000. So your margin of error is 35 plus or minus 3. So your proportion is 32 to 38%. Now these are in percentages, so if you transfer them over, it's 0.32 and 0.38. Now, if you want to get the plausible value for the total number of people, you have to multiply those proportions out. So 0.32 times 50,000 is 16,000. 0.38 times 50,000 is 19,000. So, if we went back to our skeleton sentence, it is plausible that the total number of people in the population who support the proposed legislation is between 16,000 and 19,000. So let's see which of the values are plausible here. Well, 350, 650, and 31,000 are all not going to be in between our interval, but 16,750 will be on our interval. So that is going to be your plausible value in this case. Okay, this is our last topic, percentages. This is a big one. I would say there's always 2 questions on percentage type questions minimum on the SAT. I think there was one SAT that was crazy high amounts of geometry and constants that didn't have 2 questions, but I think all of the other ones I've taken have had 3 or more. So with percentages, the first thing you want to do before solving anything with these type of questions is create your equation. You always want to write down your equation on that piece of paper. Make sure you know what your equation is. And you want to assign variables to problems in context. If it says blank percent of animals from a year, assign that whole animals in a year to like a variable like C or something. So your percent of, like if I had 60% of B is your actual percentage. It's 0.6 times B. Your percent greater or less than means plus or minus the percentage from 1. So if I had 60% greater than B, so it's 100% if you from 1, a 1 or 100 percentage, it'd be 1B plus 0.6B, which would give you 1.6B. Once you start understanding how these percentages work, you don't have to do this 1B plus 0.6B step. You can automatically know 60% greater than B will be 1.6B. You're just adding 1 to whatever you convert this into a probability. And I have this shown in example for the bottom of percentages. A is 50% greater means that A is 1B plus 0.5B. A is 50% of B means A equals 0.5B. They will try to trick you up a lot on the SAT with those types of problems, so that's why I went over that specific part. So, last year, 200 students enrolled in an interior design program. This year, the number of students who enrolled is 147% of last year's number. So, 147% of last year's number is just 1.47 times whatever last year's number is, which is 200. So it wants to know how many students are enrolled this year. Well, we already have our equation. The students that are enrolled this year is 1.7 times 200. 1.47 times 200 is 294. So 294 students enrolled at the interior design program this year. What is 10% of 370? So 10% of 370 is 0.10 times 370. If you plug that into Desmos, you should get 37. And yes, it is 37. Now these are where your problems get much harder, so really follow along closely here. Positive number A is 230% of the number B. So whenever you see is in any sort of problems, is means equal. Is means equal. So A is means A equals 230% of B would be 2.3B. And so once you get to this comma, you have your second equation. A, it says A is again, so A is 60%. A is means A equals of number C. So A equals 0.6 times C. Oh, I'm going to use a capital B for this because my B's and 6's are very close. If C is P% of B, so we want to, this is what it's asking for. It's asking for the value of P, so we want to get C equals blank B. We want to get it into this form. So what we would have to do to get it into this form is plug one of these in. Since A equals 0.6 times C and A equals 2.3B, you can plug either into the equation. So we'll just plug in A equals 0.6 to that top equation. So A equals 2.3 times B. So let's plug in 0.6 times C. 0.6 times C equals 2.3B. And then we want to get it in that C equals form. So we're going to divide both sides by 0.6. And that's not going to affect your B, so we're just going to divide it in Desmos by the coefficient. And that is going to be your decimal. C equals 3.83B. So if C is P% of B, which the following is closest to the value of P? Well, we haven't converted this number into a percentage yet. 3.83 is none of your answer choices. But to convert something into a percentage, you need to move the decimal place 2 points over. So 3.83, to convert it into a percentage, you would put the decimal point right here. And that is your percentage. It would be 383%. So C is 383% of B. So your answer choice would be D. Does everybody get how I did that? These questions are usually hard part of Module 2, close to the end. So this is, once you understand how these questions work, this is a really straightforward question to get some good points off of. And my biggest thing is knowing that is meant equals to. The population of city A increased by 7% from 2015 to 2016. So increased by 7% means 100% plus 7%. So from 2015 to 2016, it went 1.07, 107%, or 1.07 greater than 2015. So if 2016 population is K times the 2015 population, what is the value of K? It would be 1.07, because that 7% increase means 1 plus the probability once you transfer 7% over, which is 0.07. So your answer is C, 1.07. The number A is 70% less than positive number B. You see that A is again, so A equals 70% less is 1B minus 0.7B. The number C is 60% greater than A, so C is, it says C is, so you know to put that equal sign. 60% greater than A, so it'd be 1A plus 0.6A. The number C is how many times B? Well, the first thing I'm going to do is I'm going to simplify these equations, because you can simplify this. 1B minus 0.7B is 0.3B, so A equals 0.3B. And then 1A plus 0.6A is 1.6A. C equals 1.6A. Now, we want to know the number C is blank times B. So we're setting it up as this again. That's what we're looking for. We want to know what we're looking for. So C is how many times B. So we would plug in B to this equation. A equals 0.3B, so you can plug in 0.3B to that 1.6A. C equals 1.6 times 0.3B. Now we'll have to do 1.6 times 0.3. Let's get out Desmos for that. 0.48. C equals 0.48. B. So your answer would be C is 0.48 times B.